example that you just went through where you were talking about the major renovation at the end of 10 years. The problem was talking about a major overhaul every 10 years, so you'd calculate that 2 more times, or would you multiply that number times 3? Wouldn't your maintenance cost change each year?
Well, they're saying that the major overhaul every 10 years is $200,000, and they didn't say it changed. Now, the problem could have said that the overhaul changed every 10 years, but it didn't. The annual maintenance cost was changing every year, but the major overhaul was not changing. Now then, you're right, there would be, if this thing lasts 40 years, then at the end of 10 years there would be one of these. At the end of 20 years there would be one of these. At the end of 30 and 40. But since they're all $200,000, the annual cost per year would be the annual cost of $200,000 spread over 10 years at an interest of 10%. And then you just apply that uniformly. That'd be true for every year, right?
Okay, thank you.
Okay. Okay, now this example 9.6 is an example. This contractor's bidding on a project, and the owner requires completion of the work by, and they got an EOM, end of the month 12. So you're going to work months 1 through 12. And the owner is going to pay the contractor in one lump sum at end of month 14. And so to pay for the day-to-day labor and material costs on the project, the contractor is going to get a loan from the bank. So he's going to get a loan from the bank every month of $100,000. So presumably he'll borrow $100,000 at the end of month 1 and pay it out. At the end of month 2 he'll borrow another $100,000. He'll do this through end of month 12. And then he won't get paid until the end of month 14. And so he says, thus at the end of month 12, the contractor will have borrowed from the bank 12 payments, $100,000 each, for a total of $1,200,000, and owe the bank $1,200,000 plus the interest. And the owner is scheduled to pay at the end of month 14, at which time the contractor will pay the bank. How much should the contractor include in the bid just to cover the cost of financing the job? And I'm going to draw a little sketch of that, and I'm going to draw a sketch. And here's my t equals 0, and here's 1, 2, 3. And I'm going to put a break in the line, and then here's 9 and 10 and 11 and 12. Oh, missed. Okay, excuse me. Okay. Now what we've got is we're borrowing this money at every one of these months through month 12. But there's a month 13 and a month 14. Now what we can do is we can use the equation or the table to find the future worth of this at month 12, including the interest. With the interest being I is 1% per month, and we got 12 interest periods, so we can find the future worth. Now we can take that future worth at the 12th month, and we can find its future worth at month 14 using n equals 2 and using a 1% interest rate. So you'd have to do that in 2 steps. You see, your equation wouldn't allow you to find the future value out here directly because there's not 2 payments here. It's required. The future worth is here, and you've got this annual series. So you find the future value here, then you've got to move this future value here to the future value at the end of the 14th month. So what you do is you'd put it here as a present worth, take this future worth here, put it down here as a present worth, and find the future value of that 2 months later. Then when you got that, he saw that, and he got it's going to be blurred a minute, but he got $1,293,700. He'd actually borrowed $1,200,000, so the interest is $93,700. So he would put that down as a cost in his bid. Any questions? Oh, no, I'm not going to go over it because we're about out of time, but on page 18, it discusses problems having to do with growth and using these interest tables. You can use these interest tables for dollars. You can use the interest tables for growth in population, and you can use the interest tables for growth in power consumption or whatever. And this is discussed on page 18 and 19 with some example problems. And on page 20, it discusses forecasting growth. One of this book that you have is a good book, and I think you would do well to plan on using it for the examination. There's they refer to to a method of computing depreciation that's called the accelerated cost recovery system that the IRS required people to start using a few years ago, and it's on page 65. Now, your book refers to it. The beginning of that, it looks like this. What's in your handout, that's about page 65, Accelerated Cost Recovery System. Your textbook refers to the Accelerated Cost Recovery System. It doesn't show you how to work any problems, but it does refer to it. And it doesn't give you a table. It just mentions it. And there are some problems here if you wanted to use that. Your textbook does discuss other means of depreciation, and it does it fine. But it mentioned the accelerated cost recovery system, but it didn't work a problem. So there are some work problems on starting on page 65. Some of the other depreciation methods are on page 71. And but other than that, I really like the book. I would suggest that if you have a non-programmable calculator, that you use the tables. I would suggest that if you have a programmable calculator, that you might go ahead and use it. But when you come to a particularly long trial and error solution where you're going to have to do a lot of guessing, I think it might still be faster to use the tables. So you ought to try some trial and error problems. See which solution you like the best, and more importantly, which one you can do the most accurately and with the fastest answer. Using the tables, I think it has the advantage that it seems to me you might be less likely to punch in some bad information in this program. Do you have any questions overall? We have to go through this rather quick. But if you think this is quick, wait till 2 or 3 weeks from now. We'll be going over